Now we'll be learning about the 6 trigonometric functions. Currently, you may only know about 3 of them, but there are actually 6. What are those 6? So these are the 3 that you know about: sine, cosine, and tangent. But in fact, there are 3 more, and they are called the reciprocal trig functions. They are called the cosecant, the secant, and the tangent. The abbreviation for cosecant is CSC. The abbreviation for secant is SEC. And the abbreviation for cotangent is COT. So what is the cosecant function? Well, it's easy. It's the reciprocal of the sine function. So that means it is 1 over sine of x. What is the secant function? It is the reciprocal of the cosine function. Therefore, it is 1 over cosine of x. And the cotangent function, therefore, is also the reciprocal of the tangent function, which is 1 over the tangent of x. Next, we'll be learning about some trig identities. What are trig identities? Well, an identity is something that is true for any value of x. Okay, so let's say we have a right angled triangle with vertices labeled A, B, and C. And this is our angle theta. Relative to theta, the side AB is our adjacent side, the side BC is the opposite, and the side AC is the hypotenuse. So based on this triangle, we shall identify the sine, cosine, and tangent ratios. So here we have that the sine is the opposite over the hypotenuse, which is BC over AC. The cosine is adjacent over hypotenuse, which means that it is AB over AC. And the tangent is opposite over adjacent, which would be BC over AB. Now, we want to see if there is a relationship between sine, cosine, and tangent that we have not seen before. What I will do is, I will take the sine function and divide it by the cosine function and see what we get. So sine is BC over AC. And if I divide that by cosine, which is AB over AC, let's see what happens. Whenever you divide by a fraction, you should invert and multiply, right? You multiply by the reciprocal. So we will have BC over AC times AC over AB. When I multiply these two, I notice that both of them have AC, which can cancel, and I'm left with BC over AB. But what is the expression BC over AB? If I look closely, I see that that is the tangent function. So here we have our very first trig identity. The tangent function is equal to the sine divided by the cosine. So let's see if we can find another relationship. Here we want to see if there is a relationship between sine and cosine that is deeper than its relationship with tangent. So let's see what happens when we square the sine, square the cosine, and add them together. What do we get? Well, let's see. What is sine? Sine is BC over AC. If I square that, then add it to the square of the cosine, which is AB over AC, what do I get? Well, let's see. If I square BC over AC, that will simply be BC squared over AC squared. If I square the AB over AC squared, that is also simply AB squared over AC squared. Here, I am adding two fractions that have the same denominator, so I can just keep that like denominator. So I will have BC squared plus AB squared all over AC squared. But if I look at it, what is BC squared? And what is AB squared? And what is AC squared? Well, according to the Pythagorean theorem, AC squared is equal to AB squared plus BC squared. So here in my numerator, I have really just another expression for AC squared. So when I simplify that, I have AC squared divided by AC squared, which of course is equal to 1. Why? Because I have one quantity divided by the very same quantity, and that is equal to 1. No matter what the length of the hypotenuse of the triangle, AC squared divided by AC squared is 1. So our second trig identity is that sine squared plus cosine squared is identical to 1. And I should note here that I am using 3 lines instead of 2. Why is there 3 lines instead of only 2? Because this is what we call in math an identity, meaning it is a stronger relationship than an equality. What do I mean by that? I mean that no matter what value I plug into these so-called equations here, it will always work out. So since it works for all values, it is stronger than a simple equation. It is what we call an identity. And to illustrate that, we use 3 lines instead of just 2.
We are to determine the equation of the line that passes through the point 3 minus 7 and has gradient 4 in both, first, slope-intercept form, and secondly, standard form. So whenever we work a problem like this, a good thing would be to first start off by drawing a sketch. So we know the point is 3, negative 7, and it has a gradient of 4. Since the gradient is positive, that means it slopes upwards like this. That is something we had to learn before already. So when we find the equation of the line in slope-intercept form, we already know the gradient is 4m. We want to find the value of the y-intercept c. So based on our sketch, we know it should be some negative number. So let's see what we get. So we start by writing our formula. In slope-intercept form, it is y equal mx plus c. So substituting our values that we have, the y coordinate is negative 7, the gradient is stated as 4, and the x coordinate is 3. Then we simplify. 4 times 3 is 12. Then when we transpose, instead of adding the 12, we will subtract the 12 from negative 7. So c is equal to negative 7, take away 12, which will give you negative 19. So the line crosses the y-axis down here at negative 19. And therefore, our answer is y equal 4x minus 19. Finding the answer now in standard form. We start by writing our formula. Y minus y1 is equal to m times x minus x1. Substituting our values, our y1 value is negative 7, our gradient is 4, and our x1 value is 3. So simplifying, y take away negative 7 will become y plus 7, and then expanding brackets, 4 times x is 4x, and 4 times negative 3 is negative 12. So I will transpose, and then I'll have y minus 4x is equal to negative 7 minus 12, and that gives me the final answer of y minus 4x is equal to negative 19. Let's practice on these two. Number 1, determine the equation of the line that passes through the point 3, 4 and has gradient negative 5 in both slope-intercept form and standard form. And secondly, determine the equation of the line that passes through the point negative 10, negative 1 and has gradient 1/2 in both standard form and slope-intercept form. So pause the video at this point, work them out, and when you are finished, you continue in 3, 2, 1. Here are the answers.